Hello everyone. So today we are going to discuss about multicasting basics. So we know there are five uh, types of IP classes: Class A, B, C, D, and E. Right. So Class A, B, C are used for unicast routing, right? Class B is used for multicasting. So multicasting, as the name suggests, multicasting address defines a group of recipients. So if you want to transfer a same packet for multiple recipients, right, multiple destinations, then you can uh, use multicast address or a class D IP address to identify a group, right? So in this way, as a single sender or source, right, can transmit the data frame to a group of destination addresses, right? Not a single destination address, right? Please remember, multicasting address is for group of destination addresses, right? Destination addresses to transfer the data, right? So here, see, you can have a look at the diagram. Multicasting addresses, any IP address that starts with 224 dot. You have to look at the first byte of the address 224 dot to 239 dot. Right. So first byte is if it starts with 224 dot to 239 dot. Then that address is used for multicasting, right? Multicasting. So a router, actually the networking device, right, which will forward the packets uh, either for unicasting or multicasting. Router is the important uh, destination to distinguish whether the packet is intended for unicast device or multicast device, right? So, uh, it will look at the first byte of the IP address, right? Whether it is unicast IP address or multicast IP address. So, in order to identify whether it is a unicast address or multicast address, both IPv4 and IPv6, right, will use a block of addresses for this purpose. So in IPv4, we are using the range of IP addresses that start with 224 dot to 239 dot, right? So any IP address that starts with the first byte of 224 dot to 239 dot, which means it is a multicasting address, right? So multicasting applications. So multicasting is used in uh, so many day-to-day applications like access to distributed database, right? So if you want to access information which is stored in a distributed database, right? Like Google, right? Google databases are replicated in multiple servers, multiple locations. So any information, if you want to access it from the Google server, then you need a multicasting application, a multicast address, right? Then information dissemination, right? So if you want to share any information from uh, one of your branch, right, to another branch, or one of your network to another network, right? Then you can use uh, information, sorry, multicast addresses, right? Say for example, if you want to access uh, State Bank branch, right? Uh, uh, Other than your home branch, right? Then the same information can be obtained from the nearby branch, right? So, so it's a simple example for multicasting and teleconferencing, right? Teleconferencing, you can connect multiple persons, multiple people uh, with the help of teleconferencing. So teleconferencing will automatically involve multicasting, right? uh, Distance learning, right? So distance learning, and of course, uh, uh, remote learning, video learning, right? All are example lessons are taught by professors can be received by a specific group of students, right? Anywhere, anytime. So this is also a convenient application of multicasting. So the next one is the multicast, how to identify multicast and how to integrate multicasting address to Ethernet address, right? So multicasting, as I told you, multicasting address starts with 224.2 So the leftmost byte, right? Leftmost byte, the leftmost first three bits are always enabled, and in order to identify whether it is unicast or multicast, the fourth bit is always set to zero, right? Fourth bit is always set to zero in case of multicast addressing, right? Multicast addressing. So the leftmost three bits are always enabled to set to one, and the fourth bit is intentionally set to zero, right? If it is a multicast address. So 2 power 7 is 127 and 60, uh, sorry, 128, 64 and 32. If you add all these three values, it will become, the resulting value will be 224, right? 224. Then next is how to integrate multicast address to Ethernet, 48-bit Ethernet address. See, uh, the 4 bits are used to identify the network, right, or multicast address, and the next 5 bits are unused. The remaining 23 bits are used to represent the multicast addresses, right? Multicast addresses. So these 23 bits of multicast addresses will be uh, uh, inserted to 48-bit Ethernet address, right? So here is a simple example. See, change the multicast IP address 222.43.14.7 to an Ethernet multicast physical address. So we have to find the rightmost 23 bits of this multicast IP address, and then we have to replace the 23 bits of Ethernet IP address with this bits. That's it. That's the solution. See, this is the uh, right. This is the Ethernet address, right? And we have to replace the rightmost 23 bits with the IP address, multicast address, right? So we have the result of starting Ethernet address, right? So we have to replace this 23 bits with the Ethernet address. And if you don't have multicast support, right? Support, you have to use the tunneling method. Tunneling method is like direct point-to-point connection. Right? So to send a multicast packet, the process called tunneling is used. Right? Tunneling, the multicast packet is encapsulated within the unicast. Right? All the multicast packets will be encapsulated within unicast itself. Right? And then it will be forwarded to the next layer for further process. Right. So multicast routing protocol, there are two modes of multicast routing: dense mode, sparse mode. Right. So uh, so dense mode, where the routers will receive the uh, multicast traffic or packets, it will simply flood it on all of its interfaces, right? Except where the actual multicast packet is received, right? So except, so it will use the same concept of hub, right? Uh, in the networking device concept, we have discussed about hub, right? So dense mode, it will receive the multicast packet at one port, right? So except at that port, it will simply flood, flooding the packet to all the other ports. Whereas sparse mode, right, it is far more efficient than dense mode, right? So it will only forward the multicast traffic to the intended or only the particular ports, right? So dense mode doesn't stop flooding the packets, right? Until you ask router to stop, right? Whereas sparse mode only sends a packet on the request basis. Right? This is the difference between dense mode and sparse mode. And two approaches to multicasting: source-based tree approach, right? Source-based tree approach. Each router constructs a dedicated routing tree, right? So how to reach the group of destination devices. So based on that, each router will construct a dedicated routing tree for every source group configuration, right? So it is source specific. That's why they named it as source based tree approach, right? And it is resource intensive. It requires a lot of processing time and uh, memory, right? And to store all the details, right? And states, right? And the protocol, example protocol is distance vector multicast routing protocol, right? Distance vector or multicast routing protocol. The second one is group shared tree approach, right? The routing tree is shared among all the members of the multicast group, right? A specific router known as uh, Renderswitch point act as the representative source for each group, right? So the routing tree is completely shared among all the users. One router is dedicated to uh, act as a representative for the group, and the traffic, all the traffic of this group is routed to and from the render source point or the specific router, right? So it is better than the previous one, right? Group centric. But if what if the render's point fails, right? You have to uh, back up with another one. The second one is IPv6 addressing. So far we have discussed the multi-fashion basics. Let, now we'll discuss the basics of IPv6, right? IPv6. We're not going to discuss in deep detail about IPv6, just the basics. So IPv6 is 128-bit address, right? Whereas IPv4 32-bit address. IPv6 is 128-bit address, and out of 128, 40 bytes are used for header, and the remaining will be used for uh, payload, right? So address IPv6 address supports unicast, and multicast. It doesn't support broadcast, right? Uh, Whereas IPv4 will provide support for broadcasting. IPv6 doesn't provide uh, broadcast, right? And this is the header format of IPv6, right? IPv6. The version will indicate whether you are using uh, IPv4 or IPv6. And traffic class will define the type of service or class that data URL is forwarding. Flow label, payload length, next header, hop limit, and source address, destination address. So remember, see, source address is 128-bit address, right? In case of IPv6, right? Because why we are migrating from IPv4 to IPv6? Because the address range or usable IP address in IPv4 is very minimal, very restricted. So we are migrating from IPv4 to IPv6, right? So IPv6, no broadcast support, right? No broadcast support, and stateless auto configuration. So it's like a automatic DHCP process. So it will automatically advertise the need for the IP address, IPv6 address, right? It doesn't require any manual configuration, right? Address renumbering is also possible with IPv6, right? So whereas in renumbering, static IPv4 right is a painful process, right? Whereas in IPv6 it will be automatically done, right? Mobility it does provide mobility support, and no network address translation or that is required for IPv6 addresses, right? Because we have enough huge number of IPv6 addresses, and IP security is also possible, right? Even if you don't want IP security, it has inbuilt uh, IPv6, IP security protocol, right? And the header is also improved, right? Doesn't require any checksums for error checking and flow control, right? And the only problem is the support is not there for IPv4 and IPv6, right? So you need to use the tunneling method if you want to pass the data from IPv4 to IPv6, right? IPv6. There are three types of IPv6 addresses: global unicast, link local addresses, unique local address, right? So global unicast address starts with 2001. So it's a 128-bit address. If the address starts with IPv6 address starts with 2001 colon means it's a global unicast address, right? Global unicast addresses. These addresses are the same like the IPv4 unicast addresses, public addresses, right? So it is intended for a unicast destination. Whereas second one is link local address. Link local addresses will start with FE80, right? FE80. Uh, these addresses implies that the packets are intended for local use or within the network, not intended for internet or outside the network. The third one is unique local addresses. So again, it is for local communication within the network, not on the internet, right? Same like the private address concept in IPv4, right? And so as we discussed, IPv6 supports unicast addressing, multicast addressing, and unicast addressing, and it doesn't provide uh, uh, broadcast addresses, right? And IPv4 consists of two components, right? IPv4 consists of two components: net ID, host ID. Whereas IPv6 consists of three components: routing prefix, subnet ID, and interface ID, right? So the first 16 bits, right? The first 16 bits contain, specifies the routing prefix, and the next one bit will be used to identify the subnet, and the remaining bits can be used to identify the interfaces or host, right? So these are the some basics about IPv6 and multicasting, right? See, there is a clear definition between multicasting and broadcasting. So multicasting is used to identify a group of people, whereas broadcasting, no need to identify a people, right? Irrespective of the destinations, you can anyone who are present in the network can receive the data, right? That is broadcasting. Right? IPv6 doesn't support broadcasting, right? Doesn't support broadcasting. It will support only unicasting, multicasting, and anycasting, right? Anycasting. So if you have any questions, you can post it in the comment, right? So thanks for watching the video. Thank you, guys.